didn't record earlier today, I forgot. So I've got to record one for my people who miss. The very first thing I want to talk about is, hey guys, the very first thing I want to talk about is yesterday's assignment. Because yesterday when I looked at like 4 p.m., I had like 5 people per class that had done the lab. It was very small. And so that told me that there might have been an area that I could have improved on making sure people understood that so that they could do that lab. So I just didn't take attendance yesterday, to be totally honest, because I know a lot of people didn't get theirs turned in. So you got a free pass, unless you never come to class, in which case I'm still going to mark you absent. But you guys all come to class because you're listening to me. So you're not the ones who are going to get marked absent. So I want to talk about yesterday's lab. Yesterday's lab was a factors that affect reaction rates lab. And I think what I did is I assumed that you all had similar experiences to me, and maybe I didn't communicate that clearly, or I assumed something and you didn't have it. So if you were like me, when you were younger, like when I remember when I was like 6, 7, 8, and if we would go to a restaurant as a family, my parents would never let me get the soda that I wanted. They would always order me water. And so if I ever got lucky enough that they put a lemon slice on my water, what would I do? Make lemonade, right? So I'd squeeze that lemon slice, and my parents didn't always want me to, but if they weren't looking, I'd grab that sugar packet and I'd throw it in. And then I wanted it to dissolve really fast before they saw. So what would I do to make it dissolve quickly? Stir it. That's one of the factors you could have tested yesterday to affect reaction rates. Okay. And then I also used to work in a restaurant in Georgia where we make 2 different types of iced tea. There's no such thing as just one. You get sweet tea or unsweet. And when I made unsweet tea, I just had to brew the tea, no biggie. When I made sweet tea at the restaurant where I worked at, I had to put an entire pitcher of sugar in this tea. It was so unhealthy for you. But you had to put an entire pitcher in. And you had to put the sugar basically in as soon as the tea had brewed and before it had cooled, or it would never dissolve, because heat helps things dissolve. So I had these life experiences of knowing that stirring can help something dissolve faster, and temperature, heat, can help something dissolve faster. And I think some of you were a little stuck and a little confused and weren't thinking that way. So what you were supposed to do, and it's not too late to still do this lab and get points, and you should do this lab because this is a double point lab. It's worth 10 points, not 5. Is you have sugar cubes, and you're supposed to make a control and then do variations. So again, let me explain what that means. A control could be just your first experiment, your basic one. And that might mean turn the tap on cold, measure out 3 Dixie cups full of water and put them in a glass, throw in a sugar cube and watch it dissolve. That's your control. And that would mean every other experiment, you can only change one thing from the control. So maybe for my next experiment, I do 3 Dixie cups full of cold water, 1 sugar cube, but this time I would stir it. That would be my change. Or maybe I would do 3 Dixie cups full of hot water, sugar cube, watch it go. But the idea is that you're thinking about your control and you're only changing one thing at a time. Did anybody crush their sugar cubes? Did that help? Oh, I should have. Maybe, maybe not. But that's another one you could try. 3 scoops of water, same temperature as the control, but you crush it instead of putting it in as a cube. So I was hoping you would maybe use more water, maybe use less water, but you keep the temperature and the number of cubes the same. Maybe you do 2 cubes and see if that's different than 1 cube. My goal was for you to come up with different experiments and try it, and let's see what happens. So, does that make more sense of what I was hoping for? Now, if you're sitting here thinking, I only did temperature, or I only did water amounts, that's okay. If you haven't done the lab yet, hopefully I've inspired you with some things to try. I still want you to try it. I still want you to do it. I still want you to collect that data and write about the data and the Google form, okay? This Friday, tomorrow, is the last day of the 12-week grading period. That means Wednesday morning, I'm submitting grades. Actually, let's be honest, I'm doing it Tuesday. Tuesday, I'm submitting grades. And those grades determine eligibility for sports and things like that. They don't go in your long-term record, but I don't want to have you have a 0 for that lab. So you have between now and Monday to do that lab for it to be counted on your 12-week grades. I do accept work till the end of the year, but if it's going to be on the 12-week grades, it needs to be turned in on Monday so I can have it graded by Tuesday. Any questions about the lab? Okay. We are going to do a lab together in person next Thursday. And so I have sent a survey home to my remote only kids because you're going to need a few extra ingredients. And I wanted to see if you needed any extra ingredients because I can prepare them for you. One of the ingredients you need is baking soda. You probably have it in your baking cabinet, I don't know, drawer, wherever you keep other baking supplies. This is a pretty common one. We also need hydrogen peroxide. I don't have a bottle with me, but it's the brown bottle of stuff that you put on like cuts and things like that to clean it out. You probably have that as well. If not, I can provide some. And then the third ingredient, which was very hard to find last year about this time, is yeast. And you might have it in a jar or a bag or little packets. If you come to school, I'm going to provide all the materials you need. You don't need anything. If you are remote only, I need you to fill out that form and let me know what you need. And I'm going to have all of that ready to go at the front office for you to pick up next week on Monday, Tuesday, or Wednesday, because we're going to do a lab live together on Thursday. So Blaze, you missed some really important announcements. You might want to watch this recorded video when class is over, because especially being remote only, you need to know what I just talked about. So anyway, for my remote only kids, thank you very much for filling out that survey. Some of you already have, and I found some errors in my survey, like not giving you an option saying, I don't need anything picked up. So I have fixed that for the future people who will fill out the survey. And I will get supplies for those of you that indicate you need them. So today, we are going to practice covalent bonding. We're going to practice those steps, and we're going to end the period with a covalent bonding homework quiz. So we are following the 5 steps we learned on Monday and practiced on Tuesday. Let's jump right in and try drawing it for SO. Sulfur and oxygen. I want you to follow those 5 steps. And I'll give you a little bit of time to work on it, and then I'll tell you where we're at. All right, how many valence electrons do we draw for sulfur?
6.
6. How many for oxygen?
6.
How many times does sulfur want to bond? How many lonely electrons does it have? 2. How many lonely electrons does oxygen have? 2. So when we bond those, we connect those to each other. We do lonely electron connected to lonely electron. And then we draw those connections as dashes. And this sulfur connected to this oxygen 2 times. So it's a double bond. Then we look at how many dots are left over. And I see that sulfur has 4 dots left over. Oxygen has 4 dots left over. Questions? Let's try NOH. So we're starting by writing the Lewis dot diagrams. How many times does N want to bond to become stable? 3. How many times does oxygen want to bond? Twice.
Twice.
Right, it has 2 lonely electrons. How about hydrogen?
Once.
Once. So oxygen and nitrogen connect twice, and now oxygen's happy. And hydrogen can connect to nitrogen's last lonely electron. Nitrogen and oxygen bonded to each other twice, so we do a double bond. Hydrogen bonded once. Nitrogen has 2 dots left over. Oxygen has 4. By the way, every question I've been asking out loud is a fair question on the quiz. Because the way the quiz is going to be is it's going to say, draw this, and then it's going to ask you all these questions about it. So it might say, how many times does something need to bond to become stable? It might say, how many single bonds did you draw? How many double bonds did you draw? How many electrons are left over on an element? And so all the different questions I'm asking out loud, it's okay if you're not answering them out loud, but you should be able to answer them in your head, okay? So be trying to figure out why and ask me questions if you don't understand an answer. Now, would it have been okay for me to draw hydrogen down here? Totally fine, or up top or on the other side. As long as nitrogen's in the middle and it has a double bond with oxygen and a single bond with hydrogen, it doesn't matter what you put where, just the center atom matters. Let's try another guy. Let's try CH2S. I'm being quieter because I'm letting you guys do the steps. Hopefully you marked that carbon wants to bond 4 times. Each hydrogen wants to bond once, and sulfur wants to bond twice. So we connect everything to carbon. So I could ask you questions like, how many double bonds are there in CH2S? And you would tell me what? 1. How many single bonds are there in CH2S? 2. How many electrons does sulfur need in order to become stable according to the octet rule in total? And I see it has 2 here, 2 here, 2 here, and 2 there. So 2, 4, 6, 8, right? The octet rule says elements want to have 8 valence electrons in order to become stable. Are we going to be able to get these right when I put it on the quiz? Let's do another one. Let's do SBR2. So how many times does sulfur want to bond to become stable? How many lonely electrons does it have?
Twice.
2. How many times does bromine need to bond to become stable? Both of them once. So both of our bromines are going to connect to sulfur. Get S with a Br and a Br. Sulfur should have 4 unbonded electrons. Each bromine should have 6 unbonded electrons. Si, Se, I2. Capital letters matter, right? Every capital letter is a new element. So Si, Se, I2. Any questions on how to draw any of these, how to do steps? Are we ready for the quiz? So the quiz is going to ask you to draw one covalent compound and then answer all your questions based on that drawing. So keep your paper out because you're going to need to draw one more. And my remote only people, please make sure you fill out that survey today about whether or not you have the supplies that you need. So I can get them together tomorrow and have them ready for you to pick up Monday morning, as soon as Monday morning. You can pick them up Monday, Tuesday, or Wednesday for use on Thursday's lab.